This is the beginning of Unit 4, Quadratics, and today we're just going to look at the prerequisite skills, in other words, a review of some things that you've already learned in previous math classes to help you get ready for our quadratics. So the first thing I want to review is working with signs when we multiply, divide, or add integers, and also, well, any number that's got decimals as well, just combining signs, right? So just remember this. If we combine two signs together like this, if we're adding them, then it becomes a minus sign. So this simplifies down to a minus here, and then we end up with 7.1 minus 2.5 gives me 4.6. Again, anytime I've got two signs beside each other like this, I combine them. Two of the same sign becomes a positive, so that becomes a plus 1.6. And when I do negative 3.5 plus 1.6, I get negative 1.9. When I'm multiplying them, the two signs aren't beside each other like they were in A or B, but I'm looking at the numbers in front of the numbers that I'm multiplying together. So in this case, these are the signs I'm combining. So this is, slightly different place you look for them when you're multiplying. But two of the same sign, again, becomes positive, so it becomes a plus sign, and then 1.7 times 2.1 is 3.57. So just basically what you need to remember is if you have two of the same signs, whether you're adding, subtracting, or multiplying or dividing, two of the same signs, whether they're both positive or both negative, comes out positive. If you've got one of each, one negative, one positive, they always combine to come out negative. The next thing that we're going to review is collecting like terms, simplifying signs. So collecting like terms requires us to recognize what like terms are. So like terms have the same variables and the same exponents on those variables. So that's the key. So in part A, we have minus 5x, and we got minus 4x with a minus sign between them. Those are like terms. They both have that same variable, x, with no exponent on them, so those are like terms. We still have to simplify the signs. Two of the same makes it change to a positive overall, so I'd rewrite it like this. And then I just add or subtract the numbers in front. So negative 5 plus 4 becomes negative 1, and the variable stays exactly the same. In this case, I want to take off the brackets. Think of this bracket as if it was affecting everything that comes after it. Almost think about it like a distributive law thing. So I'm going to combine that minus sign with this negative, but I'm also going to combine that minus sign with this plus. So what I'll get is 2x squared, and then when I combine these two together, that becomes a plus. So plus 3x. When I combine these two together, that becomes a minus because it's one of each. And then collecting the like terms together, I've got these types of terms, x squared terms, and then I've got this type of term that doesn't have the squared on it. So that's what I'm looking for, the squareds versus, not squared in this case. So if I move those beside each other, so just rearrange it a little bit, now I've got the x squared terms together, and then the other term. Well, again, just subtract 2 minus 2 is 0. So I got 0x squareds, but I don't have to write down 0x squareds. That's really just goes away, and I'm just left with the 3x. The next example, we're going to do a little bit of substitution. Find the value of y when x equals negative 1. So we're going to substitute negative 1 in for x in this equation, then just simplify it. So y is going to equal negative 4 times negative 1 minus 2 squared plus 1. Now we just have to follow order of operations. So we always start with brackets. Minus 1 minus 2 is minus 3. Then I'm going to do exponents next, so I'm going to square that negative 3, and I get positive 9, because a negative times a negative gives me positive, so it's negative 3 squared is the same as negative 3 times negative 3. So going back to the sign thing, two negatives make a positive. Then I multiply, negative 4 times 9 is negative 36, then I add the 1 as my last step. So we're following order of operations. Doing the same thing for this one over here, we're going to put that negative 1 in and just go through the exact same steps. So I won't talk this one out, just watch as I fill it in. Okay, so there's a little bit of order of operations, a little bit of substitution. What else are we going to review? Tables of values and graphing. Remember, to complete a table of values, you either pick some x values, or as in this case, have them given to you. You substitute them into an equation and calculate what the y values are. So in this case, this is the equation we want to graph. We're going to calculate the y values by substituting the x values in, like we just did. In example 3, we did a little substitution. That's why we reviewed that. So if I substitute -2 into that equation up here, what I get is y is equal to -3 times -2 plus 4, because the x is equal to -2. So that's the substitution I did. And then I work it out. Now I don't have a lot of space, so I'll just go straight to my answer. -3 times -2 is +6. Then I add 4, that equals 10. So that's my final answer for that one. For the next one, I'd put in -1 in that spot. And so I have -3 times -1 plus 4. So I'm going back to this equation up here over and over again. And again, the reason why it's -1 is because I replaced x with -1. -3 times -1 is +3, plus 4 is 7. If I keep doing that, keep replacing these numbers, I won't write them out, but if I did -3 times 0 for the next one, I'd get 0, and then I add 4, I get 4. And then if I did -3 times +1, so again, I'm going back to this equation again. -3 times 1 would give me -3, and then I add 4 to that, I get +1. And then I go back to this equation once again, and I have -3 times 2. That gives me -6. Add 4 to that, I get -2. Now what I've got is a whole bunch of ordered pairs. Right? Here's an ordered pair. The top row, this is an ordered pair here. Oops, it sort of blacked it out, didn't it? But anyway, I'm looking at the top row. My ordered pair is -2, 10. So I go to -2 on the x-axis, up to +10, put a point. And there it is. Then I go to my next row. So this row here, -1, +7. And go to -1, up to +7, put another point. Then I go to the next row, 0, 4. Put a point at 0, 4. And I just keep doing my ordered pairs like that. 1, 1 would be the next one. 2, -2 would be the next one. And you can see I've got these points that all lie in a straight line in this case. I can draw my line through them. So it'd be something like this. So there's my graph. Then I'm supposed to identify the slope and the y-intercept. That's what this part is saying to do. So the y-intercept is where it crosses the y-axis. So the y-intercept, remember, where it crosses the y-axis, we represent that with the letter B. So B, y-intercept, is 4. Pardon me, lost my voice for a second. So it's 4. The slope is how it's changing as it's going from one to the next. So remember, slope can be found by doing first differences. On the table, what I could do is I could go from 10 to 7, I'm going down by 3. From 7 to 4, I'm going down by 3, so that's why I'm writing negative signs here. 4 to 1, down by 3. 1 to -2, down by 3. So my first differences, if you remember, are all the same. And that would be my slope. And remember, slope is represented by the letter m, y equals mx plus b. And that makes sense because if we go back to this, once again, back to this equation here, remember y equals mx plus b, we can see that m was -3, which again I can see here, and that b is 4. Calculate the first differences from the table. Subtract the y value from each one that comes after it. We just talked about that. So we're going to do first differences again. So going from -4 up to +1, we're going up the number line. We're going up by 5. Going from 1 to 6, we're going up by 5. So they're positive numbers now. 6 to 11, up by 5. 11 to 16, up by 5. So these will equal the slope of the relation. We just saw that as well. So if I want to know what the slope of the relation is, I can tell from this that m equals 5. And in fact, I could write the whole equation. Remember, y equals mx plus b. So I just figured out what m is, although I didn't write it down as m. Let me rewrite that. M equals 5. And so I know what m is. B, the y-intercept, occurs when x equals 0. So this number here, what I'm noticing is that x equals 0, what's the y value that goes with it? Well, it's this -4. That's my b. So I could actually write the equation for this, even though it doesn't ask me to. I'd do y equals 5, that's my m, x plus -4, that's my b, and then I could simplify these signs and I get y equals 5x minus 4.